So we've lost two fantastic colleagues in the last couple of years, and it's really remarkable what these two characters have done. Of course, not everybody agreed with some of Paul's results. Here's a picture of Mike Searle and Peter Molnar standing on the Karakoram Highway, contemplating his somewhat high velocity. And I really regret that Paul is not with us. And I wonder what he would say if he were. This is what I think he would say. Yeah, don't believe a word of what the next speaker has to say. He had a great sense of humor. So I'm going to summarize quickly what I'm going to talk about. I'm going to say the Kashmir Valley was flooded by a lake, 25 meters deep in the 9th century. And this facilitated the dismantling of a Buddhist ruin and reconstruction of a whole bunch of Hindu temples around the valley. I'm then going to talk about the consequences of an engineered breach by a medieval engineer in about 830, which caused a 21 cubic kilometer flood. And it transported boulders the size of small cars, let's say a Mini Minor or a Fiat. We're not talking about a large car like a Hummer or anything. I'm also going to say a bit about the possible history or prehistory of Kashmir, which may have had enormous lakes compared to the one that was released in 833. And I'm going to finish up by making some extremely wild, speculative conclusions. So we don't have a lot of time, so I'm going to whiz through this. Here's the Kashmir Valley. It's looking to the northwest, and you can see it looks like a gigantic hole. What is it doing there? Why is there a gigantic hole in the Himalaya above the main thrust zone? Well, there are shorelines on this, around this lake. Not many people have seen them, and I would like to try and incentivize you young guys to go there and have a look. You'll have to dodge the bullets, but it's well worth it. Nobody's dated these lake shores. And it seems there may have been a 460 cubic kilometer lake there at some time in the last 5,000 years. Here's a rough guide to the tectonics, very rough guide. Essentially, we've got a GPS rate, convergence rate of about 10 to 15 millimeters a year. We have a lot, décollement of some sort, and that is raising the Pir Panjal mountains, and the rate seems to be about 2 to 10 millimeters a year. It's a rather large range because it comes from different points in the range. But the important thing is that the valley exit, which button do I press? The middle one? The top one. Oh, yeah, wonderful, marvelous. Okay, so this is the only exit from the valley. Lots of rivers come into the valley, but there's only one exit. And this exit keeps going up, which means that the lake level would continue to rise unless you eroded the lake, this lip down. Now, in fact, this is a settling pond. The rivers come into the Kashmir Valley and dump their sediment load, so there's no erosive capability for the river to get out of the valley. So if you block the valley, it's really difficult to unblock it. You haven't got any fuel to actually erode the lip of the valley. A couple of other things, a consequence of this rise of the Pir Panjal is that the sediments deepen to the northeast. And in fact, evidence of that is that these temples that you find on the northeast side of the valley some of them are actually submerged and have submerged by a meter or so since they were constructed. Here's a picture of one of them. It's a view of a Manasbal, I believe, I can't remember. This one is Pendratam, that all the temples are damaged in some way. If you look carefully, these have been cemented together, but they were in fact just dry stone construction. But you can see some of these stones are not in the right place. There's no concrete, there's no steel, just a pile of stones. And one of the miracles is that there are any temples left at all. They should have all been demolished, but they're not. Here's one, an important one. Just get the scale. Here's some people here. The gigantic megalithic blocks. And if you look closely, you'll find that some of these blocks are all out of joint. This one's been moved this way, that one's moved in the same direction, this has gone the another way. This whole column here has shifted about 10 centimeters. So every time there's an earthquake, these things get jostled around and bits of them fall off. So we went there to look for stones that had fallen off and trapped small insects or bits of twig or something we could date. So we could date the earthquakes. Well, here are the known earthquakes. Notice something about this record. It's ridiculous. All the earthquakes happened quite recently, and they weren't very big. They were probably magnitude 6s and maybe a 7s or 2. We think one of them may have been a 7.6, but it's only because we've got about 4 reports from that one, and we only have 1 each from all the others. In other words, the history here is terrible. So can we get some better clues about what's going on? The weight of these things are enormous, and it's quite possible that they had to be transported around by barges, which I'll tell you about in a minute. Here's one of these mega blocks that fell off the top of a temple here. It fell about 5 meters. We were allowed to excavate here as long as we didn't move the stones, because all the archaeologists have been moving the stones, destroying the very evidence we needed. But we found one stone that hadn't been moved. We dug under it, tunneled under it, got some carbon dates, and confirmed that this temple had indeed been constructed in about 833, plus or minus 50 years. You know what carbon-14 is like, is useless. But essentially, we're able to confirm the historical known properties of this temple. And we found that this block had probably fallen down in about 1123, coinciding with one of the known earthquakes in the history of Kashmir. But nothing for the 1555 earthquake. Now, one interesting thing is all these temples were constructed about the same time in the 9th century. And here is a real ruin. This is a ruin of a Buddhist temple that was constructed between the 1st and 2nd century. And you'll notice that what's left is basically rubble. And the only things that are left are things that are too big to move, or things like this, which you wouldn't want to carve into a temple because they're just useless blocks. This was fill for a gigantic suite of temples constructed by the Buddhists on an island, I think, in the 8th century. And this is the island. It was, this is a lake that I'm showing. I'm going to talk about this lake in a minute in some detail. But here is the Buddhist monastery that was taken to bits, and bits of them are sort of lying around as construction materials near this temple Sugandesa, which I just showed you. Here's another temple that was almost completely finished and now in a partly ruined state. There are bits of temples all around here, but the interesting thing is they're all at the same level. It looks very much like this lake was facilitated the barging of these temple blocks to different parts of the Kashmir Valley. Right. Now I'm going to talk about the one lake we really know quite a bit about. This lake was described in Kalhana's Raja Tarangini. It's a rhyming couplets Sanskrit thing, which of course I didn't read in Sanskrit. I read about 6 different translations, and they may all say the same thing, that there was a small earthquake that triggered a landslide that blocked the only exit to the Kashmir Valley, and the lake started filling up. And we know the depth of the lake because we know the height of Bijbihara, which was flooded, but we don't know what depth it was flooded to. Somewhere between 1 and 5 meters is the guess. So that gives us some idea of the height of that dam. It had to be about 25 meters. What we also know is that the consequence of this flooding was that the price of rice went up 5-fold. People were, it was sort of a terrible time. There was nothing to eat. So let's have a look at the location where this landslide occurred. These are 50-meter contours, and you can see places on the south side of this gigantic mountain. It goes up to almost 4 kilometers, okay, and the valley floor is only 1,500 meters. So you have a landslide coming down here. The energy involved is sufficient to pulverize and, in fact, weld the rocks when they land. The energy released is so huge. And one of the things that happened, of course, was it started filling this thing up. And we calculated it took about 3 years to do that. How do we do that? We just took the sort of average discharge for the Bilham now and worked out how much time it would take to come up with the 15 cubic kilometers of water that you need to raise this 25 meters. Now, the interesting thing starts at this point. Here's a quick view. This ridge is called the Diaga Ridge. I haven't labeled it here. And there's a little channel here, a drainage channel. The width of the river at the point where it seems to have been blocked is there. And I'm going to show you a picture of a rock that we obtained there. Here it is. It's a fusion breccia. You can see it's a slate. It's an Ordovician slate, but it's welded by sediment, and you can actually see that this block has rotated in situ, and this is kind of welded, a welded tuff. Not a tuff, it's a welded slate, very unusual, a fusion breccia. So here is a view looking to the south of that, on that spur, and you can see here this place called Tapponnier, and this word diagal is interesting. In Kashmir, diagal means treasure or money. And there's a legend about that. So we think the landslide filled up the valley here, and it was emptied by a medieval engineer. His name was Suya. So I call this Suya's flood, but in fact it's Suya's drain, which doesn't sound so good. The fix was that Suya managed to engineer a breach of the dam. And he was boasting, saying, I know how to do this. And so the king, Amphithéâtre, said, oh, really? You know how to do this? What do you need? And he said, give me money. Okay, so the king gave Suya some money in pots, thousands of coins. And as soon as Suya got the money, he took it in a boat and tossed it in the water. And the king was kind of amazed. All his courtiers were astonished and angry. But the king said, well, let's see what's going to happen. Of course, Suya said, the villagers will now help me breach this dam. They want the money. And this is well-known legend. All the children of Kashmir know this legend. So we worked out what probably happened. It's all described in these Sanskrit rhyming couplets. The guy, first of all, tried to dig a drain through the top of the dam, and it didn't work. It was just trickled. As you well know, you can get a seepage over the top, but it doesn't do anything. So then he built a cofferdam. He didn't call it a cofferdam, of course, that's what we call it now. And he built a causeway. He lined it with stone so it wouldn't fall in. So this must have been fairly deep, maybe 20 meters deep. And then he breached the cofferdam, and he was able to enlist the hydraulic incision power of a lake breaching a dam. Now, you can do the calculations on this. The engineers actually have all sorts of empirical equations. I don't believe in the moment. I took 15 different equations that came up with a number between 10 hours and 72 hours. Okay, I mean, that's actually not a bad spread. It's, astronomically, it's a couple of days. It just took a couple of days to get rid of this dam. And when it did, it sent a surge of water downstream. We calculated this surge. You can see it is the time after the breach and the height that the water reached at different points. So this is a 30-meter surge at this point. When it gets down to Baroi here, it's only, about 17 meters. Well, 17 meters is quite a lot. It's taller than this room. In fact, you'd have troubles if you were trying to get this. It turns out the rate of rise of the water was only about 1 meter per hour or so. In other words, no, it was, sorry, I haven't got the units there. Scrap that, I can't remember the number. But it was sufficient for you to walk out of the way if you noticed it. If it happened at night, you hadn't got a chance, of course. Here's Mangla Reservoir. Of course, that wasn't there in 900 AD, but it would have filled Mangla Reservoir twice over. In 2 days, it would have overbrimmed the reservoir. It was such a huge amount of water. If you look at the details of the downsurge, this is a rather complicated picture, but here's the topography. It's a mile high over a distance of 300 kilometers, okay? 1.6 kilometers is the lip of the valley. And this is the time, this red line over here. But the interesting thing, units are here, the discharge, okay? This is the meters cubed per second, and what you see is it's going for a fairly. Sorry, I'm seeing this obliquely. This is the velocity. Okay, here's the velocity: 15 meters per second. So it basically passes this room in 1 second. It's a huge, fast river flow. Okay, let's have a look. Those are calculations, okay, theory. So if you look downstream for evidence of the transport power of such a surge, you find quite a lot of evidence. These blocks here, for example, are about the size of this car or this ruin of a car. And there's a number of empirical formula that tell you what is the transport power of a certain velocity of water. And we get quite an interesting distribution. We went to Google Earth and looked at 126 boulders downstream, and we were able to get their dimensions to an accuracy of about 10 centimeters from Google Earth. Think about that. I didn't really believe it at first, so I went to the river in Boulder, where I live, and we looked from the space at the boulders in the bed, made some measurements. So I went then down there on my bicycle with a ruler. I couldn't measure those things as accurately as you can from space, because from space you see a nice beautiful map view. You can get the height of the thing from the shadow, but when you're on the ground, this gigantic boulder, you can't actually measure it. Okay, so it's quite a useful, you might find a useful way to look at things. Okay, so what do we find? Here are 126 boulders. You'll notice the maximum diameter of the boulders is roughly 10 or 11, 12 meters here. Further downstream, when you get about 70 kilometers downstream, you run into a sudden increase in the size of the boulders. This is because it now becomes the discharge river of both the Bilham and the Neelam rivers. And so these are probably glacial outburst floods coming from the Neelam River. So you kind of lose your ability to calibrate what's happening. And now when you get to the reservoir itself was completely obscured by water at the moment. And if you look at early maps, you get no idea about the size of boulders from them because they didn't map them. Okay, moving on. That's what happened in 900 AD. Now, let's ask the question, what happened before then? If you go to the Kashmir Valley, most geologists will say there are no shorelines around the edge of the lake. But Deterra and Patterson in 1935 mapped 88 shorelines. And this is a histogram of their levels. And I'll just point out the scales. This goes from 0 up to almost 300 meters above the valley floor. And you can see there's a big cluster of them around about 50 meters above the Srinagar level. And they continue up to about 150 meters. Now, a lake 150 meters deep has a clamping stress on the main Himalayan thrust of about 1.8 megapascals. So if you remove a lake, you suddenly release the Coulomb stress and allow an earthquake. If it's about to go, it will in fact go. So you can trigger earthquakes. That's the first take-home message. The second is that there's a Neolithic level at Bilham, and nearly all the Neolithic Bronze Age sites are at about this level. So it's quite probable then that Neolithic man lived around the edge of this lake. Which lake? A lake that happened, I can't tell you the date, because when we wrote this paper, I was kicked out of India. I wasn't allowed back in. My visa was rescinded. So you guys have got to go there and find out how old this lake is. I mean, it's really interesting. because that lake may have had a glacial, an outburst flood worse than the one that we modeled, this one here. And there are some enormous lakes. This thing up here, is it really there? Well, here it is. Oh, pictures of terraces. You can see them on Google Earth. This is the picture from Deterra and Patterson's paper in 1935. We went back to the same place, had a look at them. They have all the right features of a terrace. You can see there's a flat part of the shore. Then there's a shingle layer with shells in. Unfortunately, I don't have any bits of shell to date. This is so frustrating. Okay. And there's a wave cut notch at the back. These are absolutely, perfect shorelines. And then we're left with this. This is Deterra and Patterson's. This is Dal Lake at the foot of the Tariki Harsan Hill. There's a temple up the top here, Hindu temple. But they believe this is a shoreline along here. And I'm sorry, I haven't visited it. You guys have got to go there. I mean, it's not my fault that I don't have a visa, I can tell you. Well, that can't be right, can it? All right, moving on. So here are those terraces, look, that I've mapped them out. The interesting thing is it takes a long time to fill the Kashmir Valley with 460 cubic kilometers of water. And it's quite possible that these higher terraces are faulted out of their original position, because they are tilted, I know that. However, let's just go on with the what if. Here are some calculations on the boulder transport diameters of this larger flood. Again, using the same kind of theoretical calculations. And you'll notice that we can move boulders that are 40 meters in diameter. That's the size of this room. It's enormous. What have we got? Well, we have some evidence of some very large boulders. This one is probably only 10 or 15 meters across. I think this is 24 meters. And this one is unfortunately not in the path of the Jhelum. It's an Indus Gloff, probably. Okay, let's compare what happens in Kashmir with what has happened in other parts of the world. I call them lakes of doom. Here's Lake Bonneville. This is the one that wins. Okay, this is the drainage of the gigantic Salt Lake. Here is the flood we've been looking at, Suez flood. So this is this is a logarithmic scale this way and a logarithmic scale that way. This is the height of the dam you have to breach. This is the volume contained behind it. And you can see that these other lakes that we looked at, including the highest one, are getting up towards Lake Bonneville. This is an enormous amount. These things are unprecedented. If we compare it with more recent events, here is the 1844 Karakoram Gloff. This was a glacial outburst flood, right? It was dammed by a landslide and an ice a glacial advance in the Karakoram Valley that breached. And it came down the valley with a roar. People were found washed out to sea at in the Indus Delta from this small gloff here. Here's our engineered breach. It's almost twice the volume of that. Here is the one we're talking about, the 460 kilometer breach. And here is the 2010 Indus flood. So what could such a thing do? We're talking about something that nobody's really considered. Well, here's one thing they could have done. This is a map of the Indus Valley civilization up to about 3,900 before the present. In other words, and here is the Harappan sites that have been measured after that date. It's quite possible that a gloff, an outburst flood from the Kashmir Valley, may have wiped out a lot of the transport and agricultural dependence of this society, leading them to migrate to the east. Okay, final view. Earthquakes. If you look at the Kashmir section of the Himalaya, what you find is that there's a potential for a magnitude 8.2, maybe as something as big as a magnitude 9. And if you look at the GPS rates there, you find that rates are somewhere between 11 and 15 millimeters a year. I don't really believe this large number, but Sri Devi records it a few years ago. There's a cluster of seismicity suggesting quite a broad coupling zone right underneath where the lake would be. And if just adding 2 and 2 together, if you don't have a lake, you might have a time predictable model that looked a bit like this. But with a lake, you can delay an earthquake, or you might trigger one. Essentially, this would be one of the largest reservoir triggering events we know about. So you could, we don't know what these lakes did because we don't know when they were. Finally, some hypotheses to demolish for future PhD students. I'm talking about the youngsters amongst us, okay? Sorry, amongst you. Essentially, these hypotheses can be tested. I won't list them again. Essentially, there are 4 or 5 different targets to go for. And we know so little about the earthquakes that have occurred here and the dates of the lakes. A lot of unraveling is needed. Finally, cheese. We had sloppy cheese, and we had brittle cheese, and we had big cheese from Jan Klinger. And the one cheese they didn't talk about is this one, okay? Some big cheese is past its sell-by date. Yes, I'm talking about myself and a lot of grey-haired people around the room. You youngsters have such wonderful opportunities ahead of you. I really do encourage you to go and have a look. Thanks.